Look closely at this frame. Every single point of light stretching across your screen isn't a speck of dust or a digital artifact. It is a star, a massive burning sun, much like the one that warms our own skies. And inside this single portrait, there are more than 60 million of them. You are looking at the most densely packed neighborhood in our galaxy, the brilliant, chaotic heart of the Milky Way. It is the largest and most terrifyingly detailed photograph ever captured of our galactic core in visible light. A European spacecraft stitched it together in just a little over 24 hours. But the staggering number of stars isn't the real mystery here. Hidden deep within this ocean of light are dozens of secret worlds. Frozen planets drifting in the dark, circling alien suns, including one specific world an astronomer has spent 2 decades trying to weigh. In reality, this photograph is something far stranger than a mere picture. It is a message sent across time, captured deliberately today for telescopes that won't even begin their search for years. Let's take a look at what they truly found. To understand why this image is so extraordinary, you have to understand the machine that took it. This is Euclid, a European Space Agency telescope launched into the void in 2023. But here is the twist. Euclid was built for the exact opposite of this image. Euclid's true mission is to stare into the deepest, emptiest pockets of cosmic darkness, photographing billions of faint, ancient galaxies to map the invisible scaffolding of dark matter. It is a wide-angle machine. It doesn't zoom in on isolated targets the way Hubble does. Instead, it captures massive swaths of the sky in a single blink. So, for one day in March of 2025, astronomers did something radical. They pointed Euclid exactly where it was never designed to look. They aimed it directly at the galactic bulge, the crowded core of the Milky Way. Most telescopes are blinded by this region. It is so intensely bright and crowded that their sensors are instantly overwhelmed by the glare. But not Euclid. Over a 26-hour window, it captured 9 separate exposures, each covering an area of sky larger than a full moon. To give you a sense of this mind-boggling scale, Euclid matches the legendary sharpness of the Hubble telescope, but each of its 9 shots covers an area 270 times larger than Hubble can see at once. If a massive observatory on Earth tried to replicate this exact image at this quality, it would take 2,000 hours of telescope time. Euclid did it in 26. Even in the most crowded zones where stars appear to bleed into one another, Euclid keeps them perfectly distinct. It separates one sun cleanly from its neighbor. And that sharp resolution is exactly why this image is an invaluable scientific goldmine. When we look deeper into the canvas, patterns begin to emerge. Notice the dark, winding rivers of blackness cutting across the glow. These aren't empty voids. There are millions of stars sitting behind them, completely swallowed by vast, freezing clouds of cosmic dust and molecular gas. These are interstellar nurseries, the very places where new stars are currently igniting. Look over here, and you will see tight, dense knots of light. These are star clusters, stellar families born from the exact same nebula, traveling through the galaxy together. You might also notice soft, colorful glows layered throughout the frame. Those are nebulas, illuminated from within by the fierce radiation of newborn suns. A quick note on what you're seeing: Euclid's primary camera actually sees exclusively in black and white. It trades color for ultimate stability and precision. The colors you see here were carefully layered on afterward, using data from ground-based telescopes in Hawaii, acting as a structural roadmap to help our human eyes interpret the incredible reality of the frame. Buried somewhere inside this grid of 60 million stars are 51 known planetary systems. But how we found them is one of the most brilliant triumphs of modern astronomy. It's a technique called gravitational microlensing. Every once in a great while, by absolute cosmic coincidence, a nearby star drifts directly in front of a much more distant star from our perspective on Earth. When they align, the gravity of the closer star acts like a natural magnifying glass, bending and intensifying the light of the background star. And if that closer star happens to have a planet orbiting it, that planet adds its own tiny gravitational tug, creating a brief, hours-long flicker in the light. That faint flicker is the unmistakable fingerprint of a hidden world. For 20 years, astronomers have used this patient method to discover nearly 300 planets. Every single one of them was found by staring directly at the crowded center of our galaxy, the exact region in this photograph. The math is simple. The more stars you look at, the higher the chances of catching a perfect alignment. What makes microlensing special is that it finds the worlds other methods completely miss. It doesn't care how hot or close a planet is to its star. It is uniquely built to detect cold, lonely worlds orbiting out in the frozen dark. Among the 51 planetary systems captured here, 2 hold a very special place for the astronomers behind this image. The first is a frozen wasteland discovered 2 decades ago. It is so incredibly cold and distant from its host star that scientists frequently call it the real-world equivalent of Hoth, the ice planet from Star Wars. The astronomer who originally discovered this world 20 years ago is the exact same person who fought for Euclid to take this picture. For 2 decades, he has been missing one fundamental piece of data: the planet's exact mass. Now, after 20 years of waiting, his planet's sun is sitting inside this frame, ready to give up its secrets. The second target is even rarer: an alien world orbiting not 1, but 2 suns at the same time. Normally, binary stars blur together into a single point of light from this distance. But by combining older data from Hubble and ground observatories with this hyper-sharp Euclid image, astronomers can finally separate the twin suns, proving the existence and weighing the mass of the unique world caught in their gravity. But here's the most profound detail of all. Euclid didn't take this image to discover new planets today. In fact, it can't. To catch a microlensing event, a telescope has to stare at the same patch of sky continuously for weeks. Euclid only looked for 26 hours. It didn't find a single new world, and it wasn't trying to. Instead, it did something much more visionary. It took a perfect before picture. In the coming years, NASA will launch the Nancy Grace Roman Space Telescope. Its primary mission is to stare at this exact patch of sky to hunt for thousands of new planets. When Roman catches a future alignment, astronomers will reach back in time to this exact Euclid image. By comparing the 2 snapshots years apart, they can calculate exactly how fast the stars are drifting, proving beyond doubt that a planet is there and calculating its precise weight. It is a cosmic reference point, a photograph taken today for discoveries that haven't even happened yet. Let your eyes rest on the sheer scale of this image one last time. Remember what every single one of those microscopic dots represents. Not a cloud of gas, not a distant galaxy, but a blazing sun. And current astronomy tells us that nearly every single one of those 60 million suns likely holds at least one planet of its own. Now, look at the bigger picture. Hey, this entire frame is just a tiny microscopic sliver of our home galaxy, a galaxy that holds hundreds of billions of stars in total. No scientist can point to a single pixel in this photo and promise you that life exists there. We may search for generations and never find it, but when you sit with the sheer, crushing scale of the suns laid out in front of you, ask yourself honestly, is it truly possible that every single one of them is completely empty? That is the true power of an image like this. It isn't just the 60 million stars you can see, it's the infinite possibilities hidden silently among them. If standing on the edge of this endless cosmic ocean changes how you look at the night sky, hit that subscribe button right now and join our journey here on The Cosmic Scale. Every single week, we pull back the veil on the universe's greatest, most mind-bending mysteries. Don't let the vastness fade away. Subscribe now, leave a comment with your thoughts on what's hiding out there, and let's explore the infinity together.